We're starting with Algebra Lesson 1 today, looking at what a function is, linear relationships, and slope formula. A function you'll commonly see denoted as f of x. What does this mean? F of x means that the input x affects the output y. So let's say I have the equation f of x equals 4x. X is our input. So let's say I have f of 2. That means that our input is 2, and our output is going to be whatever our function gets as a result. So f of 2 would be 4 times 2, because we're plugging in 2 wherever that input is, that x, which would be 8. So our output is 8. That is what a function is. This is what you'll often see them represented as. Sometimes you will just be given the equation, such as maybe 4x squared, and they won't say f of x, but you can kind of gather from that that is a function and x is your input. So x will always be your input. Next up, we have linear relationships. A linear relationship means that on a graph, your slope is never going to curve. Your slope is always going to be constant. It could look like that. It could look like that, look like that. But your slope is never going to curve. It is always going to be a straight line in one direction. So the way that this looks algebraically is a constant slope always has a constant in front. The slope for x that we looked at earlier. There is no squaring, cubing, rooting being done to this x. It is just x with the coefficient 4, which means that our slope would be 4. If we looked at this graphically, if our input is x, f of 0 would be 4 times 0, which would be 0. F of 1 would be 4 times 1, which means it would be 4. F of 2 would be 4 times 2, which is 8. F of 3 would be 4 times 3, which would be 12. And see how it makes that perfect little line? So that's linear. Always think of the word constant when you hear linear. And linear just means it's a straight line. So pretty simple to remember. So now we get into, I forgot the A. Slope formula is y equals mx plus b. So what does this mean? Y is going to be your output. So on a graph, you get the x value, right? You get your input, and your output is going to be what you plot on the y-axis. So if I'm given f of 2, I'd know that I have something at the point 2, and I'd plot it on the y-axis. So y is going to be your output. M is going to be a constant, and that represents the slope. It can be a decimal, it can be a fraction, it can be a negative number. M is always a constant. It is one number that doesn't change. It is always the same. X is going to be that input. So f of 2, f of 3, that 2, that's going to be your input. It's what determines the output. Another really important thing to know about the slope is that you can calculate the slope if you are given different values in a linear equation, because the average slope over an interval will be equal to the actual slope. If I have a line here, let's say that this point is 0, 0, and this point is 1, 1. If I want to calculate the slope of the line, I do delta y over delta x, or y2 minus y1 over x2 minus x1. It doesn't matter which one is 1 and 2, it just matters that you use the same point as 1 and 2. So I can't use 1 for my y and then 0 for my x for y2 and x2. It has to be 1 for both. So then if I plug that in, I get 1 minus 0 over 1 minus 0, 1 over 1, so our slope would be 1. B is the one that people forget about. B is going to be the y-intercept. So what's the y-intercept? I am given this graph right here. Let's say it goes like that. The y-intercept is where the line crosses the y-axis. So that would be right here in this case. You can find B if you are given other values. So this is really important. This will show up on your SAT, is the slope formula and y-intercepts. Oftentimes they will give you an equation and you need to solve for B in part of that equation to find a different value. So sometimes you do need to solve for B. Let's say that you are given two values of a function. So let's say that we have f of 2 equals 5 and f of 3 equals 7. We can calculate the slope of this line by taking the average values. Let's say in the problem we're given that it's linear. That means that we can take the average value of this, the output over the input, to find the slope. So delta output over delta input equals 7 minus 5 over 3 minus 2, which would be 2 over 1, which equals 2. So 2 is our slope. So now that we have our slope equals 2, we can start plugging this back into the y equals mx plus b formula. Y equals 2x plus b. So what is b? We can solve for b because we already have known values of the function. So because we know that the input is 3 and the output is 7, we can plug in our inputs and outputs. So we can say 7 equals 2 times 3 plus b. Then we have 7 equals 6 plus b. 7 minus 6, that means your b value is 1. So now you've solved for b. So that is your standard slope-intercept formula. It's called slope-intercept formula because it represents the slope-intercept. There are also other ways to represent a slope, and that is where sometimes they will try and trick you. Another way to write slope is with the standard formula. This is ax plus by equals c. This is represented differently because x and y are on the same side. So our input and output are represented on the same side, meaning we aren't solving for an input or output at this point. Normally, when you see something in standard form, you have to bring it over to slope-intercept form to solve for what it is. Let's say I have 4x plus 2y equals 8. If I wanted to get this in slope-intercept form, I would just solve it algebraically. So I'd subtract 4x from both sides, and I get 2y equals negative 4x plus 8. You can do 8 minus 4x, but it's easier to just keep it to the normal formula and put the x value before the b value. Then you still have to get rid of that 2 in front of the y. For it to be in slope-intercept form, the y has to be by itself. So you divide by 2, and you get y equals negative 2x plus 4. Now you've gone from standard form to slope-intercept form. Another thing that you need to know is some key terms. So first up, parallel. Parallel means that two lines have the same slope. A good way to remember this is that they never touch, because if they have the same slopes, they can't ever meet. Even if they have slightly different slopes, they will always meet, because eventually there's a point on the graph, whether it be in the hundreds or the millions, where the slopes will cross each other. But if they have the same slopes, then they are parallel. The second one you need to remember is perpendicular. Perpendicular means that the slopes are going like, oh my gosh. Perpendicular means that the slopes are crossing through each other exactly. Algebraically, the slope of one is the negative reciprocal of the other. The reciprocal is just the inverse fraction. Now remember, every number is a fraction. It's just some numbers are over 1, but it's still technically a fraction. You can write it as a fraction. So let's say this line right here, the slope was 4x. To find the slope for this one, if the problem says these lines are perpendicular, what's the slope of the second one? We would say, oh, so I know the slope for this one is 4. I'm going to take the negative of 4, so negative 4, and then I'm going to take the reciprocal. Negative 4 is the same as negative 4 over 1, so the reciprocal would be negative 1 over 4. So that is the slope for this line. How does this relate to standard form? So sometimes you will get a problem where your linear equation is given to you in standard form, like this. 2x plus 4y equals 16. And it says, find the line parallel or find the line perpendicular to this. Either way, you have to put this in slope-intercept form, because this, if you just try and flip this too, that's not the actual slope. Because remember, this y is also being translated. So we have to separate the variables and solve for slope-intercept form to find the perpendicular or parallel line. So if it's asking for parallel, I'm just going to solve for y. So for y equals negative 2x plus 16. So then y equals negative 1/2 x plus 4. What that means is now I have the slope of this line. So the slope of a parallel line would be the same. It would be negative 1/2. Now, if I wanted the slope of the perpendicular line, I would do negative 1/2, take the negative, so the negative of a negative is positive, so then I get positive 1/2, and then I take the reciprocal, so I'd get 2. Now that does happen to match up with that. I don't know if that's a pattern, but it's always good to just solve it just to double check. So that is how you find a perpendicular line. This is just a basic linear slope review. I think that'll be it for today. Next, we're going to go over real-world applications and representations of linear lines.